This conference will now be recorded.
Hi everyone, today I would like to give demo on Synopsys application oriented Tcl. So Synopsys application oriented Tcl. Here I would like to break the Synopsys application oriented Tcl into three words. First is Synopsys. This course will be very useful for designers or students who are planning to work on Synopsys tools or professionals who are already working on Synopsys tools to create their own automation framework. If they want to do automation using Tcl, this course will be very useful. To be frank, even it will be very useful for students or professionals who are planning to work or already working on cadence tools as well. But there are slight difference in commands compared to Synopsys. So if you just able to pick up the right commands in cadence tools, so even it will be useful, even it will be very useful for even the cadence students as well. So to be frank, so though we have mentioned it as Synopsys application oriented, even it will be very useful for students or professional who are working on both Synopsys as well as cadence tools. The next word is application oriented. So here it is not a very generic Tcl training. Here we are not, here we don't concentrate much on a simple programs like uh, uh, writing a program or script or to get some prime numbers between 1 to 50, or we will be doing a lot of like doing the bubble sort operation or whatever. So here actually we are calling this as application oriented because here we will take a design, and we will try to create our own automation framework uh, to automate our designs as well as to automate our tools on specific designs which we encounter in our day-to-day life. So being professionals or being VLSI students, we have to work on tools, VLSI tools, and we need to automate on the tool platform, right? So that's why we are calling this as application oriented. And Tcl, as you know, Tcl is basically a scripting language, and yeah, usually we call it as TCL, or we can call it as Tcl. It's tool command language. Yeah. This demo will cover extensively the contents which we are planning, to teach in our regular course, the Tcl course. Anyhow, we will be understanding the things, especially on syllabus as well as the course plan in further slides. The goal of this training is to enhance the productivity with Synopsys tools through effective usage of Tcl commands. Here actually we are explicitly mentioning the Synopsys tools, but it's not always. So even it will be very useful on cadence tools. If you want to increase the productivity, or if you want to create your own automation framework, and if you have some ideas in your mind, and if you want to do some automation, so this course will be very useful. Yeah, as I told, to make students to create their own automation framework on the tools, which will make our job very easy and effective. This is student driven course. We have a specific applications, scripting applications, as well as the project, and we will teach how to automate the things by taking a specific design. Even the students can come up with their own ideas, as well as the issues which they are facing in their day-to-day life when they work on Synopsys or cadence tools. Definitely we will incorporate those scripting ideas in our course, and we can automate those things. And we are very sure that once you are done with this course, and it will enhance your scripting skills, and you can resolve your issues by your own. Prerequisites. So this course will be very beneficial for students who are planning to work on synopsis tools like PT, ICC1, ICC2, DFT compiler, or it will be even more useful for professionals who are already working on these tools. Yeah, as well as even the cadence tools as well, like Innovus, Genus, Tempus. Yeah, here even we will expect that you have some decent basics on other coding language. Like we will expect that you know some basics like the control flow commands like if else or continue break, and there'll be some coding basics, right? We will expect that you know those basics. Yeah. Coming to the main slide, what is Tcl or TCL? TCL means tool command language. So it is a scripting language mainly developed for automating the tools and building our own automation framework. So you take any tool, not only the synopsis or cadence tools, even ANSYS like Redog, Totem. Most of the tools gives the Tcl shell as an interface to automate the tools. Even a lot of mentor tools, they also use uh, Tcl shell. So this is mainly a scripting language. Once you learn this language, you can automate the tools. Maybe some students they work on Redog, some students are professionals, they work on synopsis tools, some students are professionals, they work on cadence tools. Once you know how to write your own scripts, right, so it will be very effective, and this language will be very helpful to create your own automation framework. If you take any script, right, Tcl script, the Tcl script mainly consists of three kinds of commands. One is the generic Tcl command, another is the tool specific Tcl commands, and another is the user defined commands. Here I have made this as the red because this is our primary focus. Generic Tcl commands. So if you take the basic string commands or for each, if else, these are very generic Tcl commands. Sorry, generic Tcl commands. So we can execute these command in any platform, either in ICC2 or ICC1 prime time DFT compiler. Any Tcl interpreter can execute these commands. Coming to the tool specific commands, there are certain commands which we have to execute on the specific tools. For example, let us consider report timing. Report timing is a command which we have to execute on either prime time or ICC2. We have to execute only on those tools, right? We can't execute the report timing command, though it is a Tcl command. We can't execute that command in any mentor tools or ANSYS tools or cadence tools like Innovus. So when we write any script, right, it will have some generic commands, so any interpreter can execute these things. The next one is the tool specific commands. So only the certain tools will execute those commands. So if you work on Innovus or if you work on ICC2, if you want to execute your Tcl script, you have to use only the ICC2 commands, right? You can't take Redog or any other commands. Yeah, the last one is the user defined commands. So here we are coming to the Tcl. Here we will create our own procedures. Procedures are basically a function, and it is a piece of code. If you want to execute again and again, right, we will create our own commands. Once you are done with creation of procedure, right, procedure is basically commands, and it will have its own set of arguments. Once you source the procedures, and then every time you can just execute your commands along with the arguments. For example, if you write a small procedure for add with two arguments, like means we have to give two operands. So if we, for example, I have created a procedure with add procedure with two arguments. Basically, they are two operands. So this procedure will do the addition operation of two operands. So once I'm done with the procedure, if I source that procedure, next time if I want to do the add operation, right, just I will give add space two arguments, 2 and 3, so the output will be 5. Here actually we don't work on like the generic applications like addition, subtraction, or getting the getting the prime numbers between so and so specific values. Here we will be creating the procedures on the tool framework. Mostly we will be working on ICC2. There we will create our procedures. Once we source our procedures, next time onward, just you can pick the procedure name, which is basically a command, and you can pass the arguments. Procedure is a very big topic. We would like to cover procedures in detail in our course plan. So just in a nutshell, so we know what you mean by Tcl. The Tcl is basically scripting language mainly used for automating the tools, and if you want to create your own automation framework, it will be very useful. And the Tcl commands will have three types. One is the generic command, so any Tcl interpreter can execute this command. Next one is the tool specific command. So these commands we have to execute on only a respective tools. Next one is the user defined commands. So it is all about creating our own procedures, and we can create our own command. Tcl breakup. Here actually we are breaking the Tcl into three parts. One is the Tcl beginning, Tcl intermediate, and Tcl advanced. In the Tcl beginning, just we will be understanding the basics of Tcl construct. I would like to go in detail actually what I would like to cover in Tcl beginning. Next one is the Tcl intermediate. So here we will be working only on creating the high impact procedures, how to write the procedures. Again, we can write the procedures with non-positional arguments. We can write procedures with positional arguments. We can write the procedures with some default values. There are a lot of ways to write the procedures. We would like to go in detail about the procedures in this course. And the last very important one is Tcl advanced. Here we will be explicitly working on collections, attributes, and filtering applications. So if you take a prime time or ICC2, right? So we have to manipulate a lot of design objects. Now the question is, what do you mean by design objects? Design objects are basically primitives present in any database. If you take any netlist, right, the netlist will have a lot of primitives like nets, ports, pins, uh, timing arcs, power domains. There will be a lot of primitives. Those are basically called as design objects. I would like to cover in detail what you mean by design objects in our regular class. So so the group of design objects are known as collections. So if you take a design object called port, and port has a lot of properties called attributes. Port has a lot of properties. So there are many ways to find what are the attributes associated with each port, and we can do a lot of filtering. So if you want to get only the input ports, or if you want to get only the signal ports, there are a lot of ways actually. You can, once we know the attributes, just we can do the filtering of filtering. If we just work on filtering, right, so we can create a very high impact script. When you combine all these three things, right, so we can make a very good scripts. This is just an overview. Anyhow, I would like to cover what are the, again, the contents present in beginning, intermediate, as well as advanced. Coming to the Tcl beginning. The important stuff in the Tcl beginning are, so the first one is the important components of the Tcl script. There are a lot of components are there in the Tcl script. We use a lot of terminologies like command, argument grouping, command substitution, variable substitution, command output, command return value. So we can go in detail. We can in the regular course we can understand what are the major important components of the Tcl script. We can go through in detail. So here actually in this demo I don't go in depth in each specific terminology because it will take a lot of time, but here my objective is to cover the syllabus and also what we are going to plan in the Tcl script, in the Tcl training. Yeah, the next one is the control flow to the script. Actually there are a lot of control flow commands like if, else, while, for, we will be using in your daily life. Even the Tcl supports all these command flow, all these control flow commands, and we can use those in our in our Tcl script. So can anyone tell what are some of the examples of command flow, command, control flow commands? So the control flow commands are mainly if, else, while, for. Even we can use break and continue just to control the flow of the script. And the next one is the math expression and logical operators. So even we can do a lot of arithmetic and mathematical operations in Tcl. We use a command called expr, expression command. We can do a lot of the arithmetic and mathematical expressions. We can execute all those expressions. Yeah, coming to the data types, we have four important data types in Tcl. One is string, list, array, and the dictionaries. Yeah, definitely we will go in depth what are strings, what are list, what are arrays, what are dictionaries. Just we will cover all these in depth in the regular course. So the string has another important concept called regular expressions. That one, our primary focus is on regular expressions. Using regular expressions, you can grab the words or some specific pattern from the set of log files. Yeah, we will log files. It will be very useful. For example, the ICC2 will dump lot of log files. Let us consider it has dumped a log file. It has lot of error messages. If you want to grab all the error messages, right, you can use the regular expression concept and you can grab all those errors in the specific file. Next is the file IO operations. Yeah, the IO operations is all about how we can open the file, how we can write the file, and how we can do the copying, how we can do the read operation. It's all about how we can handle the file effectively. Because if you take any tool, right, if you take any synopsis tool, it will dump lot of log files. Definitely we have to do lot of file related operations, right? We have to open the file, sometimes we have to read the file, sometimes we have to write the file, and how we can close the file, how we can copy the file, how we can effectively grep some of the files. There is a command called globe function. We can effectively grep the files based on the pattern. Coming to the Tcl intermediate, it is all about creating procedures and playing with the procedures. I already explained you procedures are basically a functions. If you want to execute a specific task, right, then you can create a code for that task, and you can just source this procedure in the Tcl terminal. Next time, just if you execute, if you give the command name, right, so your task will be done. If you want to do any repetitive task again and again, just you can use that command. If you take the report timing, right, the report timing is a command. It is a command given by the tool vendor, and it is basically a proc. It is basically a procedure. So definitely there is a set of code which will be written in that procedure called report timing. But once you execute the report timing command, then all the associated code which is linked to that report timing will get executed. So here, if you want to do any specific task, right, you can create your own procedures and you can execute wherever it is required. So our course will definitely tell you how we can write a simple procedures, even the complex procedures, and how you can execute the procedures with argument. Sometimes you have to give some specific input to the procedures. So we will explain you how to create the procedures, how to write the procedures with argument, how to write the procedures with the default value. Sometimes if you want to execute any procedure, so even you can give the default values. Even yeah, we will explain all those stuff. And what is global variable and what is local variable, what is the difference between the command output and returned output, and how to define procedural attributes, and what are positional arguments and non-positional arguments. So this is most important actually. We will spend a lot of time in this part. So if you write any procedure, so definitely in most of the time you have to give the arguments. So if we give the arguments in a specific set of order, we call it as a positional arguments. If we sometimes if number of arguments are too high, right, during that time you can't maintain a specific order. During that time you can create your own switches, and you can even change the order of the arguments. That is known as non-positional arguments. Yeah, we can go in depth in our regular classes. And the last one is, there are 6 Tcl rules are there. Once we understand the 6 Tcl rules, then we don't make much mistake. I will explain what are the rules. If you clearly understand those rules, right, like 80% to 85% errors whatever you will do in your day-to-day life, right, it will get avoided. Yeah, the next one is Tcl Advanced. So Tcl Advanced is all about understanding the collections, understanding the design objects, and playing with the attributes, and filtering different design objects. So in Tcl Advanced, you can directly access, it will tell you how to access the collection and how to play with the attributes. Okay, in this, actually the first we need to understand what is design objects. Can anyone tell what do you mean by design objects? Yeah, okay. The design objects are, the Synopsys tool built its own internal database. If you load any netlist, the netlist will have nets information, ports information, clock information. There will be a lot of information. We call those as a design objects. The design objects are nothing but the database, the exact data, the database. It is a database of the design. Some of the examples, some of the design objects are clock, net, port, lib. These are different design objects. So there are a lot of design objects actually. So we can understand what are design objects and what are its attributes. So if you take any design object, right, I will take design objects as a clock. The clock will have a lot of properties or the attributes. So can anyone tell what are the different attributes of the clock? So the clock has different attributes like period, full name, sources, waveform. There will be a lot of attributes associated with the clock, right? So here the overall important thing is we have to understand what are design objects and what are the different attributes for each design objects. The attributes are basically the properties of the design objects. The next important thing is collections. The collections are the group of design objects. If you take the set of clocks in the design, right, that is known as the collection. So the collections are basically group of design objects. So in our regular class, I will explain what are collections, what are collection handles, how to create the collections, how to count the items in the collections, how to display the objects in the collections, how to append and design object to the existing collections, what are homogeneous collections, what are heterogeneous collections, and how to list all the attributes of design objects. If you take, I told you, right, if you take is clock will have a lot of uh, attributes. So like we have to understand how to display all the attributes for any specific clock, which is basically a design object. Yeah, coming to the attributes, already I have explained. Like we will use a get attribute command to find all the attributes of any design objects. Yeah, already I have explained. Clock is basically a design object, and it will have lot of attributes like period, full name, sources, waveform. So we can, if for example, let us consider you want to get you want to find the attribute, you want to find the attribute period of a specific clock. Let the clock name will let the clock name will be sys underscore clock. If you want to get the period of, if you want to get the period of sys underscore clock, right? So you can use the get attribute command to get the exact the period of that sys underscore clock. Yeah, like that you can easily get all the values of all the attributes for different design objects. And another most important thing is the filtering collections. So the ICC2 are all the synopsis commands, right? So they will give a very good filtering switches. You can use those switches to filter to filter lot of design objects based on its attribute. So based on the attributes we will do the filtering, we will do the filtering of collections. For example, if you want to filter only the sequential cells in the design, so how can we do? We can definitely use the filtering options. And for example, if you want to filter only the input ports of the design, how we can how how we can do? Definitely we can use this filtering switches so that we can effectively filter the collections. So here just to update you, like the beginning it just covers the basics. Here actually just I'm giving the idea, I'm not going in detail about each concept, just to explain you like what are the course, what are the course syllabus and where we are giving much prominence, and just I'm explaining those things. Okay, coming to the projects. So here you can also tell us like what are the scripts we can go into, what are the scripts we can write once we are done with this course. Even we have our own plans. We have a lot of application oriented projects are there. We can write the Tcl scripts, or even you can come up with your own plans, and if you tell right, we will help you to write your own script. Some of the examples here I have given. Script to insert buffers at the endpoint having hold violation. So when you get the hold violation, definitely you have to increase the delay in the data path, right? So if you encounter any situation like if you want to insert a buffer at the endpoints, yeah, we can write the script. We can write the script. So once we are done with this course, right, we will be writing all these scripts in our class. So yeah, and another important thing is whatever the projects we will execute, right, we will be executing in ICC, we will be executing in ICC2 shell or prime time. Based on our requirement, we will be executing these scripts over there. It is not just a generic tickle. So we will be working on the design. So we will take a design and we will create our own automated framework. We will be executing all these scripts in mainly ICC2 shell. Yeah, the next script is script to get list of sync pins of clock. So if you want all the sync pins for any specific clock, right, we can write our script. So the next one is the script to return all instance pins that are in timing path. If you want to get all the instance pins in the timing path, we can write the script. So script to report all the endpoint, start point, and the slack for 1000 failing paths. For example, if you want to get only any of the report command, the report underscore timing minus max path, any of it will give. If you give the 1000, it will give, but it will give a detailed report. But if you are only interested to get the endpoint, start point, and the slack, right, then for the 1000 failing path, we can write the script. So how to write means how to write the script very effectively to handle log files generated by Synopsys tools. And script to find the logic levels between reg to reg path. Usually the combo sits between the reg to reg path, right? The combo logic. If you want to get the logic levels between reg to reg path, we can write the script. And script to cut side rows for macro placement. We can write lot of scripts on clock tree structure. Yeah, just these are some of the examples. We will be writing around 20 to 25 scripts, and even if you provide the extra, if you provide your day-to-day life examples, right? Even we are ready to incorporate those scripts in our course. Yeah, and also yeah, the dedicated projects, and we will be writing other script based on the students' requirement. Yeah, these are the some nutshell information about our Tcl class. Yeah, and another slide. So here we will be working on Arcotop design. We will be executing all scripts. We will be executing all scripts in mostly ICC2 shell. So this training is not generic, as we will be executing on specific tools already I have covered. Yeah. So if you want me to execute even in prime time or design compiler, we are ready to do. We have all the license in our institute, so no issues. And based on your requirements, uh, we can do. And also this is student driven training. So we definitely will cover all the required syllabus in the Tcl, and the end objective is you have to become self-reliant in writing your own scripts in Tcl. And definitely we'll give a lot of examples, and we will be writing a lot of scripts in this course. And on the top of that, even if you have any things to do, right, definitely we will incorporate those things as well. Thank you.